Hey everyone, and welcome to the AWS Nordics Office Hours with me, Gunnar Grosch, developer advocate here at AWS. And this is my weekly show where I bring on AWS experts to talk about specific topics and let you, our viewers, ask any questions you might have. So if you have any questions, just pop them in the chat, and me and the guest, of course, will do our best to try to answer those. And this week, I'm happy to be joined by a returning guest, actually. Welcome to the show, James.
Thank you. It's nice to be back.
So if people didn't catch you last time you were on, maybe tell them who you are and what you're doing in your day-to-day job.
Of course. So my name is James Seward. My day job is I am a solutions architect here at AWS, working with public sectors, mostly in healthcare here in the UK.
And last time you were on, we talked about AWS AppConfig, and that is actually the topic for this episode as well, because there are some new things around AWS AppConfig and its use cases. So we're going to talk today about safe and customized configuration deployments with AWS AppConfig. So James, to kick things off, maybe we should talk about application configuration and how we've seen that evolve maybe over time.
Yeah, sure. So sort of over the years, I think the thinking around application configuration has evolved somewhat from configuration being sort of baked into the application itself. And maybe that looked like configuration directives that were actually part of your code, perhaps, sort of variables that you declared. And then maybe that changed to sort of extracting those into some sort of configuration file that lived with your code and was deployed with the application. But, again, sort of to get that rolled out and updated, the process meant that you had to deploy the whole application, to whatever your fleet was. And so that could be potentially, quite disruptive. You're effectively doing a code deployment just to change some configuration value.
Right. And even with modern practices like CI/CD, it means that every small little change you have to do takes time.
Right. Yeah. And, sort of every change is sort of inherently risky. You're going from, the running status quo to introducing some change by deploying and potentially restarting the application, that kind of thing. So the sort of process for that, or the thinking around that, then evolved to extracting the configuration from the application and making that a separate deployable. And so what you would do is you would have the configuration file that you'd maybe extracted from your application previously, and you would have some mechanism to push that change out to your fleet, so your hosts or your Lambda functions, whatever we're talking about for your particular use case, but you'd push that out as a separate thing to the application code. So that's hopefully a much less risky deployment to sort of roll that out. And you can still apply, sort of the CI/CD principles there. So your configuration lives in a code repository. So that gives you all the usual best practices and benefits around that. So you can have, you've got versioned configuration. You can see what changed by whom and why, hopefully. And you can do things like pull requests to get two-person reviews of your configuration changes before they go out. And then obviously you can have sort of pipelines that validate and roll out that configuration to your application.
I think you're touching on something that maybe answers my next question, which is because I commonly hear, why can't we just use Amazon S3 store configuration there, or put it into a DynamoDB table, for instance? But you talked about knowing who made the change, having that version and so on.
That's right. And so, storage backends like S3 or DynamoDB, and there's myriad others that you could choose from as well. These all sort of will achieve the goal of storing the configuration. Some of them might even do some kind of sort of version storage, so you could use S3 versioned objects, for example. But they're really, what you're looking at there is sort of the configuration storage itself. It doesn't give you the other parts of the tooling that you might want around well, like I said before, sort of like, the changes that were made, why, by whom, and so on. And there's other things to take into account here as well. So, for example, if you've got a configuration file that you're storing in S3 and your application loads that, then to deploy your new configuration, then you might have some process that sort of takes this configuration file or maybe builds it from a set of others and pushes it into S3. And the question is then, how does the application then know that it needs to load this configuration? It's got to maybe poll S3 sort of every 5 minutes or something. Maybe you have some other method of sending a signal to all of the applications that they need to fetch and reload the configuration. Or maybe you've got something like, I actually had this in a previous job. We had an application that ran, or a little script, I should say, that ran sort of as a cron job. So sort of every 5 or 10 minutes, it would fetch the latest version of the configuration file from S3, write it to disk in the applications directory, and then sort of send the application a signal to reload the file off disk. That worked, but there's risks with that as well, because sorry if I'm cutting you off when you had a question. Maybe I'm about to answer it in advance. For things like that, you're now at risk of, for example, a bad configuration file getting pushed to S3. So maybe you've got a syntax error in there, or maybe it's a semantic error where you've got, a number that like negative when it shouldn't be, or it's just out of bounds somehow. And now if you've got this thing where every 5 minutes, all of your fleet fetches and loads this configuration file, if there's an error in it, you risk within 5 minutes, and possibly even, at exactly the same time, depending on how your scheduling is set up, your application will sort of load this bad configuration file and either just sort of fall over and stop working, or start sort of misbehaving and working incorrectly, depending on what's going wrong with your config. And depending on what you're tooling around sort of your application management and your operational tooling, depending on what that looks like, that could be a difficult thing to recover from. You could be stuck having to sort of connect to each host individually to correct the error and start the application back up again.
Right. No, I was just smiling because been there, done that. I think that's a common pattern at many companies and many builders, that it's easy to create those scripts or code bases that then fetches that configuration. But it also means that it's something that you have to own. You have to own that mechanism, how to do it in a safe manner. And then every piece of code that you own, well, it's something that you have to maintain, make sure that it continues to work in the way that you want it to work as well. So maybe we should then talk about how we're doing it at AWS and at Amazon.
Yeah, so Amazon sort of has, I think, been on this journey. I mean, this is sort of, as it were, secondhand information. My role at Amazon is not a software development engineer, but I have a keen interest in that as a topic and how we work internally. I mean, particularly that sort of feeds into advice I can give our customers when they sort of say, well, how does Amazon operate, and how can I get, the sort of operational stuff that Amazon does? And Amazon then has been on this journey. We sort of had this internal tooling that was developed over a number of years that sort of did this process that we've described, right? It let you have your configuration as a separate artifact to the rest of your code. It would be versioned and stored in something like Git. And then there was this tool that would let you roll it out in a safe manner to the fleet of like hosts or Lambda functions, whatever your execution environment is. And this sort of, it gained a number of features based on, our own requirements and sort of as this environment developed, us figuring out what best practices would look like. So, for example, one big difference is it doesn't just roll out the configuration to the entire fleet all in one go. It sort of does it over a period of time. And so it will, if you've got, say, 100 hosts running your application, it will start by rolling it out to, say, maybe 5 of them. And it will give it, sort of like 5 or 10 minutes. This is all obviously configurable, but it gives it a bit of time for this new configuration to be used by some of the hosts in your fleet to make sure that it doesn't cause them to, say, fall over or start emitting errors or that kind of thing. And then, sorry, go on.
Yeah, go ahead. Yeah.
So as this, as this configuration is sort of tested by a small number of hosts, like your confidence in the configuration grows, and the service will then deploy it to slightly more hosts and give it a bit longer to make sure there's no errors, and it can sort of roll it out safely across your entire fleet. And what it can also do is monitor alarms that you define. So you say these alarms represent the health of my application, and should those alarms or those monitors go into the alarm state, then this service will automatically roll back the configuration across everywhere that it's been rolled out already. It will roll it back to the previous version, because we generally assumed that was working fine before you started your your rollout that just failed. So this gives you the sort of the confidence to be able to say, well, I can, start rolling my configuration out, and if it causes problems, I'm not going to take the whole service down.
Right. And this all sounds familiar if you're familiar with CD, continuous delivery or continuous deployment practices, to have that safe way of rolling out, in those cases, code changes. But now you can continuously do configuration instead and do that without making code changes.
Yeah, it's very much the same principles as like you say, it's stuff you see for code deployments and so on, where you sort of have like a canary host that runs the new version of the code for a while before that you roll it out to the rest of the fleet. So yeah.
So maybe 11 minutes into the show, we start showing what we're actually talking about.
Let's do that. So yeah, let me share my screen here. So this is the home screen, the console for AWS AppConfig. So this is the externalization of the service that we've been talking about. And there's a few sort of concepts to get your head around here for setting up AppConfig. And they're really sort of, you can think of them as a couple of layers of containers for your configuration to be deployed in. So at the top level, you have this concept called applications. So you can see here I've got two applications. One is called Lambda Demo App and one is called EC2 Demo App. Sadly, inspiration did not strike while I was building my demo environment. But this gives you a way to say, well, the stuff that I'm going to keep in here is only related to this one particular application. So then if I dig into, say, the Lambda Demo App, then you can see sort of here in the middle, I've got these two other things that are contained inside it. The first one is labeled configuration profiles and feature flags. This is where your actual configuration lives. So AppConfig generally will let you, your configuration file in AppConfig can be anything. Generally, it's expecting it to be something like a JSON file or a YAML file, but it can literally be anything that you want to put in there. I did build a demo previously where I was actually storing sort of like image files in there, so I could roll out image files with AppConfig.
Maybe this is a good time to mention a bit what type of configuration we're seeing customers use it for, or whatever type configuration it could be, basically.
Yeah, so like I said, it can contain pretty much any configuration. I think most customers I've seen are using it for things like sort of structured, configuration file formats. So JSON and YAML mostly. Those are probably the best choices to use with AppConfig, assuming it works for your application, of course, because AppConfig actually has built-in features that we can look at shortly that do things like validation of your configuration file. So before you even get round to deploying this file out to your hosts, AppConfig can examine the file and make sure that it's got the right fields in it, that the values are sensible, all this kind of thing. So you can actually intercept a bad deployment before it goes too far. So the other thing that lives inside your application in AppConfig is this concept of environments. So this is a way that you can have, for example, like a production environment, and then a QA environment, and then a test environment. And really, the way that they interact is you deploy a version of your configuration to an environment. So you can have version 5 deployed to your QA environment because you're testing that out, and your production environment can stay on version 4, for example. So it's really, the environments are just a way to say, which version of a configuration is applied to which sort of set of hosts. So if I just jump into what this configuration looks like. So this one is what's called a hosted configuration. That means that this configuration file is actually stored by the AppConfig service itself. So you can see that I can sort of view my versions of the configuration that I've had in the console. I can create and delete versions. I can compare them. And you can do deployments into this storage, the AppConfig hosted store, using things like CloudFormation and the SDKs and so on. So you don't have to come and do it in the console. That just makes a bit of a better demo, I think. AppConfig can also pull your configuration files from other sources. So like you mentioned S3 earlier, you can actually use S3 as the storage location for your configuration files. And you can tell AppConfig, I want you to load the configuration file to work on from S3. So you can actually use that as like the backing store. And there's a few other options as well. So you can use things like parameter store and so on. So this configuration file, and I hope the text is big enough there. This configuration file is just a little JSON file for my application that I wrote as a demo. So what the application does is inside a Lambda function fronted by API gateway. It receives an HTTP request, and it simply transforms the text it receives. It actually just takes it as part of the URL as a quick and easy way to get the text. And so you can see I've got configuration options here for, do I want to reverse the text, so sort of emit the letters in the reverse order? Do I want to make it all uppercase? Or I can sort of do a combination of the two by modifying my configuration. So maybe if I jump into the code, I can show you sort of like how my application is going to access this configuration, because that's sort of the bit we haven't really talked about yet. We talked about how you might load your application configuration prior to AppConfig, but I think we need to look at sort of how AppConfig is going to work for this. So this is the code for the Lambda function. So this is a little JavaScript function, and the code on the screen, sort of starting about line 9 here. This is the handler that executes when the HTTP request comes in via API gateway. And what I'm using here is actually I was going to say it's a Lambda feature, but it's also an AppConfig feature. So there is a feature of Lambda called Lambda extensions, which allow you to have, you can sort of think of it as like a sidecar for your Lambda function, which allows you to have, some sort of helper process running alongside your own function code. And AppConfig, the service, provides a Lambda extension to make it easy to access the service. So you do need to modify your application code to fetch your configuration from AppConfig. So you can either do that using the AWS SDKs, or in the case of a Lambda environment, you can actually use the extension, and the extension takes care of all of those details for you. What it gives you is this local endpoint. So you can see here that I'm actually fetching from localhost over HTTP. And this is how the extension inside the Lambda execution environment shows up. So we just need to make this HTTP request to a particular port, which is passed in for me by the extension. And then we request for the application ID and the environment ID and the profile ID. So these are the container things that we looked at in the console just now. For the sort of triplet of those things, you request what is the current configuration. And in the background, then, the Lambda extension will make the API call to AppConfig on your behalf. It will fetch the configuration data, and then it will pass it back to your application. What it will also do is it will handle things like caching that configuration. So if you have a Lambda function that's being invoked at a very high rate, you don't want to be making a call to AppConfig each and every time you're handling a request. This is going to potentially slow down your application response time, and also you have to be careful of sort of API access charges for AppConfig. You don't want to be hammering this service. It's not designed to be used that way. AppConfig itself, when it returns the data, will tell the extension roughly how long the extension should cache it for. So this is sort of tuned based on, is there a deployment going on at the moment or not? So having received the data from our request to the Lambda extension, there's some sort of boilerplate here for the rest of the screen where we're sort of loading the data. It might come in as sort of multiple packets and so on. So we're assembling the configuration. But the key thing is that once all of the configuration has been downloaded, I can just load it by parsing it as a JSON string, because I know that my configuration document is a JSON file. So we can skip past this. So we've got some error handling, vaguely error handling for a demo app. And now we can sort of get into actually processing, what our code is going to do. So we have this event that's come in. So we've got sort of this URL path. That's the bit we're going to try and uppercase or reverse, depending on what the configuration says. And our configuration sort of appears as this config object that we've loaded out of JSON. And you can see here we've got transform uppercase and transform reverse, the same as we had in our JSON. And if uppercase is true, then we do that transformation. And if reverse is true, then we do that. And then we return to the user sort of a message saying hello and giving them the modified path. So Is it time for a live demo?
I think so. Fingers crossed.
Let's see how this goes. So if I just make a request to that endpoint, so I've already got the API gateway endpoint set in my environment just to make it easier for me to run the command. So I'm going to make an HTTP request to it. And we can see that at the moment, the configuration I have deployed to that Lambda function is transforming the text to uppercase, but it isn't reversing it. Right, so let's see if we can deploy a new version of this configuration. So that tells me that the current version of the configuration I have deployed is this one. So transform reverse is true and transform uppercase. Sorry, transform reverse is false and transform uppercase is true. But I've got a version ready here, version 3, where both of them are enabled. So I'm going to deploy that to my environment now. So I'm going to do start deployment. I'm going to deploy to my demo environment, version 3 that we just looked at. And this deployment strategy field here, this is the thing we were talking about earlier about how quickly do you want to roll out this configuration change across all of your environment. And AppConfig lets you tweak this quite a lot. So it provides a couple of sort of examples out of the box. I have a couple that I've deployed as part of my demo environment as well. But you can see that you can really, if I actually jump into the screen here, you can choose if it's a sort of linear growth across your environment. Is it sort of, 10%, then 10%, then 10%, or is it exponential? Does it sort of accelerate as confidence in the deployment grows? And then you choose sort of, what size step that's going to be and how long it spends at each step. And then the important thing here is we also have a bake time. So once 100% of the deployment has been rolled out, AppConfig actually waits for whatever amount of time is specified here as the bake time, monitoring the alarm that you've got set as the thing that it should watch, just to make sure that nothing else is going wrong. Maybe it takes 30 minutes after you've rolled out the configuration before errors start showing up.
Right.
So you would have a bake time to cover that. So I'm going to go for instant. I feel like living dangerously, so we'll kick that off. So you can see that because I said instant for this deployment, it's already complete. If I picked a slightly longer interval, then we'd be sitting here waiting potentially for this process to run to completion, which does not make fascinating television. So it's completed. The bake time for this was also set to nothing, so it's happy that it's all finished. So if I just return here and rerun the same request as before, you can actually see that my Lambda code has picked up that configuration change and has immediately, responded to it. Now, if I wasn't talking so much, what I could have done is kicked off the deployment or maybe used a slightly slower deployment strategy and then come back to my terminal window and started making this request repeatedly. And what we would have seen is the change wouldn't have applied quite immediately, but it would sort of over the period that we had set for the deployment time, it would then start showing up. Because AppConfig is sort of slowly rolling it out. Now, in my case, with this environment, I've really only got one concurrent execution environment for my Lambda function. But if you had a very busy application where you had multiple simultaneous concurrent executions going on, you would see that sort of spread across all of those environments over the time that you had set.
I think an important thing to note there when it comes to AWS Lambda is that it doesn't mean that you will roll out on a per user basis. It's per invocation. So one user could get the new version, but the next request could give them the old version, depending on the deployment.
Yes. Yeah, so that is, that's not necessarily something AppConfig itself can help with. That's something that you need to make sure that your application is going to handle correctly. So maybe you roll out, some configuration that enables, say, a feature flag for a user. And maybe they sort of load a page of your application and they see this new feature enabled. And then when they try and use that new feature, the request they make at that point goes to a host or an instance of the function, which has not seen that flag enabled yet. Your application needs to understand that even though it hasn't seen the flag enabled, it might get a request for it and not sort of just fail with an error, for example. So, there's sort of some work you have to do beyond just saying, oh, well, I'll put my configuration in AppConfig. You have to reason about if I'm doing a deployment, and half my fleet has the feature turned on and half the fleet does not, how am I going to make sure that that's a good experience for my users?
Right. So if you just joined us, this is the AWS Nordics Office Hours. I'm joined by James today. We're talking about AWS AppConfig and configuration management, how we can do that in a safe and continuous manner with the help of AppConfig. So James has just shown us a first demo of using AppConfig and with using an AWS Lambda function and the Lambda extension, which helps us use AppConfig with just a few lines of code basically to be able to fetch our configuration.
Cool. So one thing I did mention earlier that I did say we'd revisit is the fact that AppConfig can also do sort of validation of your configuration for you. So maybe if I sort of walk you through some of the stuff I have set up for that. So just have to remember where it all lives. Here we go. So for my configuration here for my Lambda app, I've got set up what's called a JSON schema validator. So there's two types of validation that AppConfig can do, and you can choose to do neither of them, one or other, or both if you want. Actually, I think I have both set up on my EC2 app, so I'll jump into that and show you the other option in a minute. So the basic version that I have here really is you can actually use the JSON schema to describe what your application configuration should look like. So where I said earlier that, see a lot of customers just using JSON, for example, this is one of the reasons, to go with it, because these features are built into the service. You could, of course, do your own using a Lambda function. So if I, this is the schema that I had in the console, but reformatted so it's not all sitting on one line. So I won't sit and explain the ins and outs of the JSON schema language, because that's not particularly interesting, but you can sort of get a feel for what you can put in here. So the key thing is this sort of properties map. So I can say that there are two properties I'm describing, transform uppercase and transform reverse. I've got a bit of a description in there to help someone who's new to my application understand what the meaning of those fields is. And I've said that they're Boolean. So if I try and set those to, say, like an int, or I made them a string with the literal word true inside, this could be a problem. And so the schema is saying they need to be Boolean. And then down the bottom of the file at line 15, I'm saying these two fields are required. So you can't get away with not putting one of these fields in. They have to be present. And then the other bit that's of use here is line 4, which sort of goes in hand with the last bit and actually says, we're not going to allow any other additional properties in this file. So if I sort of make up my own value and I sort of do transform French, for example, as a new key in my configuration file, that will also fail the schema validation because I'm not allowed to have things that the schema doesn't define. So using this reasonably straightforward syntax, you can sort of create like this validator in AppConfig to say, I need you to check that my configuration matches these properties. So if I jump back to here, I actually have a version of my configuration, so version 2 here, that I wrote earlier, where I've added, again, inspiration did not strike, so I have other thing true as an additional property in my file. Now I'm allowed to create this because maybe I need to create a new version of my configuration in advance of some release, and I haven't updated my schema yet. So I've got a version of my configuration here that is not matching my schema. So let me try and deploy it. So it was version 2. I'm going to deploy it all at once. You can see AppConfig has actually raised an error and stopped me starting this deployment to tell me, this is sort of the JSON schema error message, as it were, but it's telling me I've got properties which are not allowed by the schema, and that one is other thing. So, I haven't even been able to deploy this bad configuration document out to my application. AppConfig has actually prevented me from running this deployment.
So you can still store the new version, but it is at deployment time that it will then do that validation.
Yes. Yeah. So like I said, maybe you're sort of evolving your application. It will support this feature in the future. You need to push the configuration in, but at the moment, the schema isn't going to allow it to be actually deployed.
Right.
So let me just switch from my Lambda demo environment to my EC2 demo environment, and I'll just show you the other type of validator that I mentioned. So this environment, this environment doesn't do the same thing. It does something slightly different. It just basically renders a web page. But I've got a JSON schema for it as well. And actually, so one of the things that's in there is the HTML background color for the web page. So that's one of the things that I can change with my configuration. But I want to actually do a bit more validation than just saying the background color needs to be a string. I want to make sure it looks a bit like an HTML hexadecimal color code. And so what I've got is a Lambda function that AppConfig will invoke and pass the configuration document to as part of the deployment process and say, before I deploy this, can you tell me if it's correct? So the Lambda code for that looks like this. So you can see it's only really 4 or 5 lines of actual Python code that's doing the validation. So the first thing we need to do is AppConfig will pass us the configuration content. So this is our JSON document with our configuration inside. It base64 encodes it and puts it in the event. So I need to get it out of the event and decode it, and then I can load it as a JSON object in order to work on it. And then what I'm going to do is do a bit of regular expression magic. I am a bit of a fan of regular expressions. I know they're not to everyone's taste. So broadly, this line says, we want the value of background color in my configuration content to start with a hash. Then I need 3 instances of 0 to 9 or A to F. So this is my hexadecimal characters, optionally followed by another 3, 0 to 9, A to F. So I can use the short HTML color code, or I could use the long one, but I can't use one that's too short or too long. And if it doesn't match, then I'm going to throw this error saying that background color must be a 3 or 6 digit hex string starting with the hash sign. If everything matches, then I can just fall off the end of the function. So AppConfig interprets the successful completion of the function as the configuration having been validated. So I don't even need to sort of return anything specific to AppConfig. I just need to let the code finish successfully. And so this now means that I can sort of validate my configuration that I'm about to pass to my other application to make sure that not only is it syntactically correct with the schema, it's semantically correct with the contents of the configuration fields.
Yeah, and I'm not saying that regex is simple, but this, as you said, it's a quite simple example of how you can use it. But this Lambda function could basically do quite advanced things to validate that configuration for you.
Yeah, definitely. I mean, anything that you can sort of think of about your configuration that you would need to validate, as long as you can sort of describe that in code, then you can write that validator. So maybe you've got, you can say, well, the value of this field can be between 0 and 10, but if I have another field present, then it can be between 0 and 20, for example. So you can sort of, whatever complex logic you would want to do your validation of your config, you can just put into the Lambda and tell AppConfig to use that.
Cool. All right, and the other part that you touched upon, maybe you're getting there, but you touched upon the rollback feature and having a CloudWatch alarm in place.
Yes, so let's lives in here. So these are done by environment, which would make sense because I mentioned earlier that your environment can represent, for example, production versus QA versus like dev. And obviously you don't want a deployment in production to be scuppered by one of your devs making a mistake in their environment and setting the alarm. So when you, well, say when you create, but as you create or later on you can update an environment, you can specify a CloudWatch alarm that AppConfig should watch in order to determine if that environment is healthy. And you can actually add multiple ones. I've just got one in my demo environment. This role over here is because AppConfig needs a role in order to be able to describe the CloudWatch alarm. It doesn't sort of automatically inherit permissions in order to describe stuff in your CloudWatch service. That would be not the way that AWS works and thinks about security. You have to explicitly create a role for AppConfig to do that API call. So I've got this this alarm that it's going to watch. And so what I can do is I can start a deployment. I'll use the EC2 demo environment since I'm in there in the console. So I'll do a deployment that's going to run for a minute or two to give me time to set the alarm. And then by way of demonstration, I've just got a script that's going to change the state of the alarm to red so that AppConfig will abort the configuration and it'll roll me back. So having said all of that, let's give it a go. So I have my configuration here. I'm going to let me just get to this here. So I've got my new configuration. I'm going to roll it out using this one. So linear 50% every 30 seconds. And this also has a bake time. Oh no, has a bake time of 1 minute. So I've got a deployment of 1 minute and a bake time of 1 minute. So assuming everything goes to plan, all of my fleet would be updated and AppConfig would consider it a success after 2 minutes. So let's kick that off. Okay, so we're now deploying. So what I'm going to do is just run an AWS CLI command to set the alarm state for that alarm. Oops. To alarm, not to OK. So now, if we watch the console, hopefully, demo gods permitting, we will actually see that this changes the status from deploying to rolling back or rolled back, depending on how quickly we catch it. Roll back already. And so what it's done is it's any of the hosts that saw configuration version 2 will now see configuration version 1 again. And this deployment has sort of been rolled back in its entirety.
Right. And in this scenario, it could be that we're rolling out a new configuration and something in that configuration makes our application not work as intended. So it triggers an alarm. That could be latency, or it could actually be errors shown, or anything that we have CloudWatch alarms for, basically.
Yeah, so anything that you can have a CloudWatch alarm for, you can use for this. So, you can pull metrics from a load balancer, for example, or from your function execution, like you say, sort of latency, that kind of thing. And don't forget, you can also do stuff like if your application is having its logs streamed to CloudWatch logs can pull metrics out of the log lines that it's seeing and turn those into metrics that you can create alarms on. So you can even do sort of alarms based on, a certain thing showing up in my log files, or, too many of a certain thing showing up in my log files.
Right. Yeah, and I think these two things now, with validators and with the connection to alarms, I think that really speaks to the safety part of it that you talked about earlier, how you can do safe rollouts of your configuration.
Yeah, definitely. I mean, there's these two parts to it. You want to be able to hopefully be sure that the configuration file that you're about to deploy is as correct as you can make it. So that's where you've got the JSON schema validation, for example, and then the Lambda validation let you sort of say, are the right fields present? Am I not adding additional fields that shouldn't be there? And then the Lambda function lets you do sort of the more advanced validation around, are the values of the field sensible, and do they match whatever rules my application needs them to contain? I mean, maybe, for example, you've got like an allow list of account IDs who are allowed to perform a certain action, but your application isn't going to work if there's more than like 500 identifiers in that list. So you can just do something like count the length of the list and validate that.
Right. So this is AWS Nordics Office Hours. I'm Gunnar, joined by James. We're talking about safe configuration deployment using AWS AppConfig. And there's quite recently, I can't even remember the date, James, but you probably know this. Quite recently, there was an announcement about extensibility when it comes to AWS AppConfig.
Yes, I'm not going to try and guess the date because, I mean, time flies here, right? There's been times where people have said, "Oh, when did that feature come out?" And I said, "Oh, about 2 weeks ago," and it turned out to be 3 months back. So, but yes, quite recently, depending on when you're watching the playback, maybe. AppConfig added this feature called extensions. Now, so this is different to Lambda extensions. This is AppConfig extensions. And really, the way to think about AppConfig extensions is they give you these extensibility points, or you might think of them as, say, hooks, like lifecycle hooks, for while you're performing actions related to your configuration. So there's a few that you can actually use. They are before you create, or as you're creating a new version of the hosted config. So I showed you earlier that I could actually create a version of a hosted configuration which didn't match the schema validator or the Lambda validator as well. And you just wouldn't be able to deploy that later. But maybe you want something that validates the version of the configuration as it's created. And then the other hooks that you can take advantage of are as you start a deployment, and then there are sort of notification hooks that aren't able to interrupt or modify the workflow, but they just receive notifications so that you know how your deployment's progressing. So that start step, which is when AppConfig sort of extends the configuration deployment to the next group of hosts. Baking, which means all of them have got the configuration and it's waiting to see if the alarm fires, and then complete and rollback. So that the first two events there can, the pre-start and the pre-create configuration version, they actually receive in these are Lambda functions, of course, they receive in the Lambda function invocation a copy of the configuration that's either being created or about to be deployed. And they can actually halt that creation or deployment, or they can modify it. So you can say, I need to inject a particular value into my configuration, or you might say, instead of failing my configuration because it's got a value that's out of bounds, maybe I'll just sort of coerce it to the maximum value for that. So you can actually sort of do this. And of course, like I said, you can sort of stop the process entirely. So there's a few a few AppConfig extensions that AWS provide. So there's the feature flags helper is sort of a built-in one for a particular configuration type, but we have this thing where you've got like an integration with Jira, so you can have Jira tickets automatically updated as configuration versions are rolled out. We can integrate with CloudWatch evidently. So this is our service that lets you do, for example, A/B testing. So you can actually have the configuration that's presented to different hosts or Lambda functions as part of your fleet receive the A/B configuration rather than it going to the user directly. It actually sort of goes to your deployed code. And then the last three here, EventBridge, SQS, and SNS, are sort of really around receiving notifications for the lifecycle events. So you can have lifecycle events published to EventBridge, and then you can sort of hook that up to, frankly, whatever you like. That's one of the nice things about EventBridge. Or if you just want to send notifications to SQS or SNS, then we have sort of built-in things for that. So actually, I won't go through the full demo, but I actually did hook up the EventBridge one. And what I did was, let me just find, so you have to go to the thing here and say associated resources. So you can see this is the EC2 demo app I've associated to the EventBridge extension here. And so what happens is whenever I do a deployment with my EC2 application, it's going to post an event to EventBridge, and then I just created a simple rule that sends that event straight to CloudWatch logs. So over here in CloudWatch logs, you can see, for example, this one is the CloudTrail log. This one is, that's CloudTrail as well. This is the problem with my subscription filter, matches. There we go, matches everything, including CloudTrail logs. So this is the event that the extension sent to EventBridge. So you can see this was the completion of a deployment. So the detail type is on deploy complete. And then it's got some other information there about, what was deployed to where. So you can use this with something like EventBridge to sort of, if you've got some more automation that needs to follow on from the deployment of your configuration, maybe you need to sort of flush some caches somewhere or automatically make you a coffee or something, you can hook that up to EventBridge and have that, automated.
And this was on the application level that you connected this, so we can see that we have the environment as part of that event. Yes.
So what you can actually do, go back to the correct tab, when you add a an extension to a resource, depending on what the extension says it supports, you can sort of attach it at one of those 3 levels. So in this case, I attached it at the application level. But if you only wanted to get events about deployments to your production environment, for example, then you could do that just by attaching it there.
Cool. So those are the AWS AppConfig authored extensions. But that's only part of it. Leading question.
Oh, well, I'm glad you asked me that. So yes, you may have spotted that in my extensions view, I've got one I didn't talk about, which is this change calendar one. So you can actually author your own AppConfig extensions that receive whichever lifecycle events it is you're interested in, and then perform whatever actions you need. So as usual with sort of everything in AWS, the magic glue for this is Lambda again. So these are Lambda functions that AppConfig will invoke and pass the event structure into you. So you can, in the case of the pre-create and pre-start lifecycle hooks, you can, if you want to, you can interrupt the flow and prevent it from going ahead. And otherwise you can just inspect the event and take some action as needed. So I've, by way of demo, I've hooked this up to Change Calendar. So I'll just talk quickly about Change Calendar. Change Calendar is another feature of AWS Systems Manager. It lets you build a number of change calendars that can sort of be blocked or open to say whether your environment is okay to have changes deployed to it at a particular time or not. So I've got a calendar here, which is called Demo Calendar. You can see its state is default open. This means that unless I put something in my calendar otherwise, deployments can go ahead. And this integrates with a bunch of other things in Systems Manager as well. And so what I've done is made an AppConfig extension, which will consult my change calendar. And if my calendar is closed, then it will reject the deployment. So today's the 24th. So I'm going to create an entry in my calendar for today. We'll start at midnight tonight, or midnight this morning, and we'll finish at midnight tonight. Make sure the time zone's right. So I now have a blocked entry in my calendar. So my calendar says I shouldn't be doing any deployments today, the 24th. So then if I go back to my change calendar thing here, that is my Lambda environment. Yes. So because this is attached to my Lambda environment, it should now prevent me from making a deployment to this environment. So if I just try and deploy a previous version of my configuration, whoops, if I press the right buttons. So you can see that my extension has failed the deployment request, and its message has been passed back to me saying calendar is currently closed, try again after, and then it actually gives me the time window, or the end of the time window that deployments are blocked. So that's something my code is doing. So I can jump into that in a second. But the power of this is that you can sort of integrate with whatever tools you have or you need, and then you can sort of use that to increase the safety of your deployments, because maybe you've got an automated tool that's going to kick off deployments. We talked about doing continuous configuration earlier, but maybe for whatever reason, you've got a blocked day for deployments now, sort of some late breaking issue, you just want to stop all deployments for the day. And so this would stop that continuous configuration pipeline, for example, from going ahead.
Right.
So a bit like the validation code, I think the code for this one is reasonably straightforward. So this is the Lambda code for the extension. It does a couple of things. The first thing is you can define parameters for your extension. So you can name the calendars that it should consult, for example. So it's not statically configured. As you attach your extension to your environment, you can say this environment needs to look at this calendar and that environment needs to look at a different calendar. So this is sort of parameterization. So my function is going to receive the calendars from there. It takes a comma separated list and it just splits it into a list of strings that it can consult. Going to make sure that I've got at least one calendar, because I don't want to be trying to consult 0 calendars. And then what it does is it uses the AWS Boto3 SDK for Python to query the calendar state from Systems Manager. So you can see that's just a single API call of get calendar state, and you can pass it a list of calendar names. So I don't even have to, do multiple API calls for this. And then all I need to do is when I get my response, if the calendar state is closed, you can see here I'm raising that error message to say try again after the time that it's open. And in this case, if it's all good, then we just need to return a successful status code, and AppConfig will let the deployment go ahead.
So compared to the Lambda validator, in this case, you are returning a 200 in both cases.
Yes.
That's right. Yeah.
Yes. So might make a few people wince that you're returning an HTTP 200 status code for an error. That is just the specification here. So you can see that I return HTTP 200, but you have this sort of error field set to blocked.
Cool. So you mentioned that there were different, this could happen in different parts of that deployment. So this one happens at the beginning, well, actually before starting the deployment.
Yeah, so this is connected to the pre-start deployment hook. So like I mentioned earlier, there's two types of hooks. There's ones where the name of them starts with pre and one where the name starts with on. And the ones where the name starts with pre, your code can modify or prevent whatever change it is. So either creating a configuration or deploying one. The others, so sort of on deployment start and on deployment complete and so on, AppConfig actually invokes those Lambda functions asynchronously, so they can't modify the deployment and they can't interrupt it. They're really there for receiving notifications about the progress of the deployment.
Very cool. All right, James, we are approaching top of the hour, so I think it's time for us to wrap up. Any last thing you want to mention about AppConfig that we didn't touch upon?
I don't think so. I think that's the majority of the thing. I guess one thing that I mentioned briefly that we haven't fully looked at is if you want to do something like feature flags in configuration. So you want to deploy application code with a new feature, but have that disabled until the time that you're ready to make use of it. AppConfig actually has a configuration type specifically designed for that. So if that's something that would match your use case, then I guess start with the documentation or reach out to your SA if you have one. There are features there for that if you need it.
Yeah, and one of the great things about that is that you don't have to change actual configuration to toggle. It is actually a toggle that is either on or off, basically.
That's right, yeah.
Very cool. So this has been another episode of AWS Nordics Office Hours with me, Gunnar Grosch. And today I've been joined by James Seward from the Public Sector Solutions Architect team. Is that correct, James?
Yes.
And James, just a quick wrap up of what we've touched upon today.
Yeah, so we discussed different ways of deploying configuration, the ways that you would hopefully reason about it for sort of more modern usage without sort of monolithic configuration sort of burnt into your application. We talked about safety considerations for, the way that you can move fast but safely. That's what you want to be doing. You want to be able to roll out configuration sort of, without going through a massive process for it, but you need it to be safe. That gives you the confidence to move faster later on. And then we sort of went through some of the features of AWS AppConfig to show you the way that it can deliver on those requirements. So you've got things like hosted versioned configurations. You've got things like schema validation and Lambda validators. You've got things like automatic rollback by watching CloudWatch alarms. And the new feature of extensions that lets you sort of hook into various points of the life cycle and sort of control them as necessary.
Very cool. I think that AWS AppConfig is one of the hidden gems in the AWS list of services. It's a service that I think a lot more companies would benefit from using. So very happy to have you here, James, to talk about that today.
Thank you for having me.
And with that, thank you all for watching today. And thanks again to James. And we will be back with another episode quite soon. Thank you all.